Hello, welcome to Free Will, Science, and Religion. I'm Chandler Klebs, and I'm here with George Ortega, Mike Walsh, David Joseph, Mitch J., and Trix Slattery. And before we started recording this podcast, somebody mentioned acausality. And so we're going to talk about acausality, the idea of true randomness, about that some people believe that things happen for no reason at all. And even though I think most of us lean towards determinism, I mean, I know I think everything is cause. I don't think of anything happening without a reason. Some people, like Trick Slattery, are more skeptical about the idea, thinking, that it's not logically impossible, but perhaps so. It's worth discussing nonetheless, and it makes no difference as far as free will is concerned because whether what you do stems from prior causes or true randomness or happening without a reason, well, then you are not the first cause of it. And the subject of a first cause is heavily related to a causality. So George, maybe you should start us out with your take.
All right, so the idea is like for something to be uncaused, by my understanding, would mean that nothing could exist before that something happened. And the reason I say this is because we live in a universe that evolves moment by moment, state by state. In other words, like the Big Bang, which is the first known instance of the universe, who knows what happened before that? But the Big Bang completely caused the universe at the second moment. It's the complete cause, because again, when I'm saying universe, I'm saying everything. What we know to exist, what we don't know to exist, it's everything. So, like, the only thing that could have caused the second moment of the universe is the Big Bang. Okay, so if we apply that the universe, moment by moment, stage by stage, state by state, causes itself, in subsequent moments, then we apply this to this question. Then if we're going to posit that something happens without a cause, and again, this is exempting the potential first cause, which transcends logic to my understanding. But if we're going to exempt that, anything after the Big Bang, if we're going to posit that it may potentially be uncaused, we have to also posit that the universe did not exist before that event happened.
Okay, can I go?
Yeah.
All right. So I understand that seems intuitive that everything has a that after the Big Bang everything just kind of causally aligned. Each slice of time you can see causes the next slice of time and so on. But if we can imagine just a one time slice and then the next time slice with something in it that wasn't caused by the time slice before it, we can basically imagine an acausal event. We can understand that this event just popped into existence within this time slice that previous didn't have a cause for it. It didn't have something that led to that event happening. So we can kind of imagine that the universe still exists. You still have all the causality in the universe, but yet in this one time slice of the universe, that this event happens that the previous one wasn't a cause for. So you can just imagine that just kind of popped into existence. So logically, you can say that type of thing could technically happen. I mean, there's no logical case against that not happening, basically.
Well, Trick, if I understand you correctly, I think what you're saying is that something outside of the universe could, enter the causal sequencing or development or evolution of the universe.
I'm not saying it would be outside of the universe because that implies a cause. I'm saying that it just appears within the universe without a cause. There's no spatial or temporal determinacy to it. It would be just something that happens.
So yeah, please allow me to jump in here. So yeah, when we are arguing for determinism, we often refer to this causal chain, and we say, very loosely speaking, everything had a cause. But clearly, there is a logical flaw when we say that. Because before the universe, there was another state. You can call it the pre-universe, whatever terminology you feel comfortable with. But clearly, originally, whatever that means, there had to be a time when stuff was already there. So no matter what sort of existence we live in, there had to be some stuff that was always there that was not caused.
Well, you have two different scenarios. If it was always there, then you have basically an infinity. So you don't ever have a starting point. It's just an infinite.
Exactly, which means no cause.
Or you can have a starting point in which it wasn't infinite, and it was acausal. The first event was non-caused event, basically. So
Agreed.
those are basically your two options that you can go for for the beginning of whatever.
Well, I mean, rephrasing one of those options, if you keep going back in time, the universe at each moment, because again, we're basically, that's the most general conception of causality, keeps going back. In other words, like the previous state of the universe caused the subsequent, and that, in other words, like there's an infinite number of causes, and under that scenario, nothing is uncaused because there's always a cause. If we keep going back in time, there's going to be an endless number of causes that precede whatever we're considering.
But we kind of don't know that. We don't know what came before the Big Bang, basically. So we don't know if there's an event that was acausal or if it's just an infinite regress, basically. So it's just something that's out of our ability to know. We don't have the.
All right, can we apply empirical, like our laws of nature to this? For example, there's two conservation laws in physics. One is the conservation of mass energy, and the other is the conservation of momentum. Now, these two laws are relatively unique in physics in that there's never been a known violation. Momentum is always conserved. Hold on, Mitch. Let me just finish.
Okay.
So, so basically, if, let's say, just taking momentum is what happens is like you have one particle interacting with a second particle, and the momentum in that interaction is never lost. It'll be imparted from one particle to the next, or it'll be part of the interaction. It's never gained or lost. So let's say you have one particle gaining momentum by its interaction with the other particle, then we have to say that the interaction caused the shift in momentum. So like if every interaction in the universe involves these particles that are moving through space, then I think we'd have to, concede that momentum has to be a part of every particle interaction.
Mitch, did you have something to say on that?
So in quantum physics, there are so this is where this is not my expertise. My background is in mathematics, not in physics. But from my understanding, there are certain quantum phenomena that occur that do demonstrate a violation of the conservation of energy. Strange things happen. Yeah.
Mitch, yes, no. There's violations of conservation of energy, and there are violations of conservation of mass. But
wait, hold on. What violations are those?
Actually, these are some that I've heard, but like my learning has been, and I don't know the specifics, but my learning had been that there are violations or potential violations of energy and potential violations of mass, but when you include them as mass energy, there hasn't been known. But Mike, you probably know more about this than we do, so.
Well, as far as I know, one of the things in quantum mechanics that appears to be uncaused are the existence of virtual particles that exist inside quarks. And so they appear to just appear out of nowhere without any cause, but they exist in an extremely short amount of time. And from what I understand, it doesn't violate any fundamental laws of physics, because anytime you have matter, you have gravity, and ultimately it all equals down the energy down to zero. So the existence of matter is positive, the existence of gravity is negative, and it all balances out to zero. But it does seem as if it has no cause. But it could either be the case that it has a cause, but we just don't know it yet because we don't have a scientific theory that can explain it, or it truly doesn't have a cause. Those are our two options.
I'm for the case that that logically an acausal event could happen, but when it comes to virtual particles, it's not really the case that it doesn't have a cause. Virtual particles are kind of, what's often used for analogy for a virtual particle is a wave in the water. So basically you have water, and then all of a sudden a wave forms in the water, and that wave didn't come from like another wave. Basically, it just. But virtual particles actually come out of the quantum field, basically. So there is actually something there that causes virtual particles. So that I don't. When people use the word that's why it's called virtual particles. But when people use virtual particles, it doesn't imply acausality, even though I think acausality isn't necessarily illogical. On George's take regarding the conservation laws, it could be the case. I mean, it could be the case that if conservation of energy is true, that does restrict somewhat our ideas on acausality a little bit. The problem with conservation laws is those are applied to a total of the system. So you could have a reduction of one thing in one area of the universe, as long as you have something happening in another universe that compensates for it. Then you've conserved the energy, or you've conserved the momentum within the totality of the universe. So a lot of people theorize on quantum mechanics that something like that happens, where you have this compensation thing happening. So I don't know how that would work, but yeah, that's one. I think George is right. That is one technical problem for acausality, at least on the physics front, not on the logical front, but on the front of that one physical rule.
Well, in terms of logic, can we suggest that causality?
Yeah.
Go ahead, Mitch.
Thanks. Sorry, please continue.
Well, I was just going to throw out one question, and I think it's leading to what you're going to say, George, and that is causality something that we think should be arrived at a priori, or should it be arrived at a posteriori?
And either way, I think whether it's a priori, a posteriori. In other words, like for example, is it another way to frame this is it just a physical law, or is it also a law of logic? Because in other words, like for example, let's say we take the Big Bang. We have absolutely no empirical evidence of what happened before. So in a certain sense, we could say that we can't know whether it was caused or uncaused. But in a certain logical sense, if causality is also a logical principle, we'd have to say, well, while there's no evidence, logic, whether a posteriori or a priori, would dictate that that the Big Bang was in fact caused. So.
Allow me to. So, for any listeners who might be getting confused right now, just to simplify what we're saying, is this an issue where you can just make a logical argument, or do you need evidence? Is it one or the other? And I think here, as Mike was kind of pointed out, it might not be that clear. It might not be clear all the time what is needed in order to make a particular argument. However, when it does come to the issue of free will, I contend that it's a priori. In other words, I don't need physical evidence to back up my claims, although I might anecdotally provide an example using certain physical phenomena or situations we are familiar with. But when it comes to acausality, perhaps it's not as clear if we can just argue it logically.
All right, so can we reach an agreement that that this principle of causality is not simply a principle of the quote-unquote physical universe, but is also a logical principle, or are
the principle itself is logical, meaning you can logicize what causality is, but it's not necessarily logical that causality encompasses all events. So you have events, and you have the ways those events can come about. I'm saying it's not really a logical principle that every event that happens is a causal event.
All right, then can we then argue that the best defense for acausality, or the best assertion, the strongest assertion that we can give for acausality is that an event may be uncaused, because it
Well,
seems it
I
seems
would think.
logically impossible to kind of like prove an uncaused event.
But George,
Well, I
like I
would.
said, sorry, please.
I would just say that the strongest evidence for acausality is probably that it's not logically impossible to have acausality.
Right. Especially when we talk about the beginning of the universe. I think that's the strongest evidence. Because, George, you sometimes operate under this assumption that the universe is infinite, which is, I think, a little bit unclear.
Well, and
I've
I
got,
agree with you,
right?
Mitch. I agree with you completely. In other words, to me, that the question of whether the universe is, infinite, eternal, or finite, temporal, transcends logic. I can't see how logic will answer that.
Right. So when we talk about that, the pre-universe or the early universe, whichever way you want to describe it, this is when we get into situations where whether you use a religious framework or a secular framework, people get confused sometimes talking about what is nothing, what is something. Could it be possible there was at a time nothing or close to nothing? It's like, and this is strongly related to this idea of causes. So I think that's the strongest argument for acausality, because if there was always something, whatever that means, and Loris Cross has wrote extensively about this and given some great topics about, given some great lectures about what physics has to say about nothingness.
Yeah, and it
Um,
wouldn't be a case for acausality. It would just be a case that of the possibility of acausality.
agree.
So yeah, so you don't we don't really have evidence for acausality, at least currently. So
All right, but wait a minute. Let me apply this to like a classic kind of like an argument. So it's possible that things are acausal. Is it just as possible that there are unicorns? That unicorns exist? We just haven't found one.
Hey, this is my time to jump in, guys, once he mentioned unicorns.
Chandler, that's yours.
Look, yeah. See, here's the deal, guys. Because obviously, we've been doing this episode for about 20 minutes. Or no, it's 17 minutes. Okay. Well, anyway, yeah. Obviously, George and Trick and Mitch and Mike Walsh have all had some to say about, is this a logical or is it a physical construct? And I have to admit, it's going way over my head. I may be executive producer of this podcast, but I'm also a confused listener because I'm listening to you guys. How about you, David?
Yeah, I'm with Chandler actually. I'm starting to feel the pull of religion, where they just offer you a book and says God did it. God does it, and there's a book that says it. That explains it all, and I don't have to worry about it. But I don't want to derail the conversation, so
Well, okay. Well, I have a few things to say about it because, like, as far as a causality is concerned, I'm a hard determinist. I consider the concept so laughable that I've never paid much attention to it. And it's very difficult to grasp that. However, I do think George has a good point. As soon as we allow for the idea of a causality, if that's even within our accepted field of study or discussion, well, that does open the possibility of other things like unicorns and floating teapots around planets. And
Yeah. Well, let me just say,
No, not
it's
really.
possible that unicorns exist. I
Yeah.
mean,
yeah,
that's
actually,
that's not
yes.
a big
Right.
problem.
So my point. So my
Yeah.
point then is under the principle or the logic that a causality is possible. Then are we then saying that anything is possible?
No.
Nope.
No, no.
Square circles aren't possible.
All right. Right. Oh, interesting. That's good. That's good.
Perhaps it would be say that there's nothing logically impossible about a unicorn, a horse with a horn, for example, and there's not necessarily anything illogical about a floating teapot out in space. I mean, some astronaut could have left it there anyway, But I guess we are saying that while we all agree that free will is an incoherent idea because it would be exempt from both causality and acausality. It seems that the opinion so far of a lot of you is that it's not necessarily a logical impossibility in the same sense as free will. So it's
Correct.
interesting, but what I would like to mention, since we're talking about acausality, is what would be the implications for, say, science or religion, because, we already know it makes no difference as far as free will is concerned. But since this is a free will, science, and religion podcast, what would it do to what would it do to science and all our the standards of having evidence and explaining the theories of why things happen if there was no why, if there was no cause? I mean, it pretty much obliterates science.
But Chandler, let me answer that briefly. I'm not sure if there. You're saying if there was no cause,
Right,
right?
right.
If things weren't caused.
Yeah, because then there would be no causal explanation. There would be no theory to test. So you're
Right.
just
Well,
left with.
you know what that would result with. I think it would result with what we have now. In other words, right now, there's never been an empirical evidence of an uncaused event. The most we can say is that something is perceived and we don't know what how it came to be. We can just see it, but we don't know its mechanism.
Right.
So we might need to conclude that although acausality is a quote unquote logical possibility in that it makes it's coherent, that there's absolutely no evidence of acausality, and every event of which we have sufficient knowledge we know to be caused. So to the best of our knowledge, everything is caused.
Well, that's the part that's the problematic, because every event, we don't know that every event is a cause, at least on the quantum scale. We on the macro scale, we could probably postulate what the causes are, but the problem is when we get down to the small, we don't really see the cause. So we just don't know what the cause is, if there is a cause. And we know that for certain events, those causes have to be non-local events. So which kind of confuses things even more. So if as soon as you throw non-locality into the mix, then you have the whole problem of something happening from a distance, immediate action at a distance, which is proven experimentally, of course, with entanglement. But you have some problems there that are just as, a lot of times, for people, unintuitive as acausal events might be. So
Yeah, here's what's interesting, guys, is that I find that for practical purposes, and I think we'll probably all agree on this. I mean, for practical purposes, when you want to know why an event happened, um, us, as a matter of practicality, we're not going to accept someone who tells us it happened for no reason. Because since our desire, for example, since it's all about pleasure and pain. If something brings us pleasure, we want to know how to cause it, and if it brings us pain, we want to know how to prevent it. And I find that as far as a causality, I feel the same way about that as I do God. I have no need of that hypothesis, just because it doesn't help us in any way alter events to cause pleasure or reduce pain.
yeah, in some ways you're right. I mean, if acausal events did happen, and if, for example, they actually had an effect on our brains or anything like that, then we'd have some major problems to contend with. We'd have events that were popping in that were causing us to do things that were basically incoherent. We wouldn't have the coherency of thoughts through time. So we would just have
Right,
things
but
that.
again, all right, but again, in principle, in other words, science is generally not about certainty per se. It's about our best understanding, our best conclusion based on logic, observation. So relative to causality, I think the best we could ever say is that it's possible that something was caused, but we could never come close to even providing evidence of an uncaused event, because the most we could say is, well, something's happening and we don't know how it happened. So
I,
that's an argument from ignorance. It's
I
basically
suppose
trying.
that, I mean, I don't know, not necessarily know if it's actually unfossil viable. Like, I suppose you could have an account where you know that something has to be non-local for it to be caused, but yet at the same time you know that it can't be not non-local for some particular reason that we find out, And in that case, then you're kind of stuck with acausality to be it's
All
the
right, but
default, basically.
but Trick, I think you're positing something. In other words, like non-locality, I don't think physics has any problem with that. So you're positing something that would maybe suggest that our knowledge of physics is incomplete. I'm not sure it would necessarily, suggest that something would be uncaused.
Oh, I'm saying if we find out that something like a non-local event, like if we could find out that certain events have to be non-local, but then we can find out that certain other events that have to be non-local also can't be non-local for some particular restriction, then we kind of have to it's falsifiable. In other words, we could say that event was not caused at that point because
Well,
there's
no,
no other
again,
option.
but that's what I'm saying. You're saying that the event, because it was like, I mean, in a certain sense, you're saying it's both non-local and local. I'm not quite sure I
Well,
understand that. I mean,
I'm putting it like, okay, so right now we know certain events have to be non-local. We don't know the cause for them, but we know that if they have a cause, they have to be non-local causes. They can't be direct causes. They have to be kind of like entangled cause, but not
Talking
really
about
entangled.
quantum entanglement, right?
sure.
Well, I'm not talking about entanglement. I'm talking about non-locality for certain interpretations. Um, so right now we
Well,
know certain
the
events
only,
at the quantum scale can't be local events because they go against certain inequalities, basically. So they go against certain theorems. If those events, if we find one that also cannot be non-local as well, then we have a problem with causality in general. And in that case, it's falsifiable. I'm not saying that we know we have this. We don't. But I'm just saying that it is something that is falsifiable if we can uh, deduct certain options out.
All right, Trick, I'm not sure that we can use as a criteria for understanding the principle of falsifiability because, for example, if we applied it to the universe, we'd have to conclude that we can't say the universe exists because that statement that the universe exists is not falsifiable. And more so, like the actual statement that truth requires falsifiability is itself not falsifiable. So like that principle has two very strong arguments, against it.
I would just give you
Yeah, but that's
finish
what
your thought
science is
first.
based on. That's our.
No, that's Popper's thing. That's not most science is based on, observation and scientific method, saying
Yeah, but
well,
that is the
falsifiability is
scientific
a
method.
very strong component of science.
Yes,
It's
the
not
scientific
accepted by everyone.
method. The scientific method is basically falsification. It went from the deductive process to the inductive process to Popper's falsifiability. That's kind of the history of the scientific method. So right now, that is our best method for the scientific
But can you see
community.
the powerful flaw in it? In other words, like you apply to like we can't with this criteria for knowledge, we can't scientifically say that the universe exists because it's not falsifiable.
We would basically say that all evidence points to the universe existing.
Exactly, that's what I'm saying. So science is much more based on evidence than this principle of falsifiability.
No, that is falsifiability. If somehow you could have evidence that the universe didn't exist, for example, us being a brain in a jar or something, then at that point it would be falsifiable that our universe that we know doesn't exist. But so it is falsifiable. It's just that all evidence points,
Well, it's just that evidence requires a universe for that evidence to be part of. So,
Yeah, but if you're saying, the known universe exists, but yet you're a brain in a jar being probed by, I don't know, something to think that the known universe exists when it really doesn't, then so yeah, it all goes back to weird stuff. But science also postulates certain axioms first, which is reality exists, for example. So based on those axioms that we grant first, then we come to this whole falsification thing for everything else within the universe.
hey, we're like at 30 minutes, so I don't know if we wanted to end this or if we wanted to extend the length of this for this discussion or what you guys wanted to do.
I don't know.
We,
We haven't really concluded much.
Right, we haven't concluded much, and we're kind of in
Yeah.
the middle of a discussion, so
Wait.
I,
I put out a question there whether causality models are a priori, a posteriori. What is everyone's thoughts on that?
well, Kant considered causality a priori. I think there's a good argument that it's a posteriori.
And
You
I
know
don't
that
even know what a posteriori means.
It just means you need physical evidence. So a posteriori means physical evidence. A priori means just self-evident or deductive. For example, if you have a deduction, that would be a priori knowledge based on some self-evident principles. You
that's a
understand?
great question, Mike. Yeah.
Like logic and math. If you're doing mathematics or logical proofs, physical evidence is meaningless. You just use a deductive reasoning within a formal axiomatic system. Okay. Anyway, look, I want to center the discussion a little bit because it did get very, very academic. And although I do enjoy talking about these things in my personal life, I feel like one of the goals we all have, everyone on this podcast at least, is that we want to sort of bring the issue of free will out of the scholarly realm, right? So I've said this many times before, but I am not an elitist. I don't want people to feel like we're just stuck in this muck of philosophy and we don't know what we're talking about, or that the topic is too difficult to approach. The the simple what we're saying here, if I can sum it up in layman's terms, is that even when you think about the universe in a different way, when you don't think about it in a deterministic way, if you want to call it acausal or random, whatever you want to say, or you say the universe permits a certain degree of acausality or randomness, despite this, there is no room for free will. None of this gives any meaning. Does it make the word free will a meaningful thing? Because free will is directly related, it's only meaningful in the context of responsibility. So
Right.
even if some things do pop out of existence, even if the universe at first popped out of existence, even if the universe is eternal or infinite, this still doesn't make any sense when we say that we, as human beings and possibly animals, as the conscious observers of our existence, we can control what happens.
I think a simple way to put it would be that there's no willing an event that doesn't have a cause because the very act of willing is one that is a causal event. You can't will something without a willer, which means that automatically implies causality. So any event that doesn't have a cause to it obviously cannot be a willed event.
Yeah, and guys, this is another interesting thing, because in a sense, the idea of willing something requires causality. In a sense, like I think that's what Trick was getting at. There's a reason why some being would will something, and I think that this has implications for religion. You know what I mean? Because the idea that things are the will of the universe or God or the will of the invisible pink unicorn or whatever, that's still a very causal concept. Whereas I think a causality, even though I don't believe it to be the case, if it was the case, it would almost make the concept of will meaningless because there would be no actual cause of why something was willed, and it would seem just as if people's will and consent and stuff like that mattered less if there was a causality. I'm not sure about that, but that just might.
Well, but to be clear, when we talk about acausality, even then, even when we are permitting for a universe where acausality has occurred or does occur, we're still not saying it's abundant with acausality. We're still not saying it
Right.
would happen all the time. So
Right. Even
yeah,
even if it's not, it could be not near us at all. There could be an acausal event in another galaxy. Who knows? It wouldn't. That doesn't necessarily mean it affects us, right?
All right, but Chandler, you just remind me. I'm not sure we completely addressed the universality argument that I presented before. In other words, the universe we define as everything, right? So, like, let's say if we start with the universe at the point of the Big Bang was everything. So, in other words, like the only thing that it could have caused the universe at the second moment of the universe would have to have been the Big Bang. And so, like, so if since we're considering the universe in its entirety, I think we have to kind of like, in other words, like there's no room for anything that's not within the first, let's say, instance of the universe to find its way in in a in an uncaused manner into the second moment of the universe. There's
See,
just there's no.
I don't see why not. Like, I don't see why everything you can't add more to everything. Like, you can't add something else to everything.
Well,
I don't
trick, because
understand.
because everything, you can't add to everything. Conceptually, everything is everything. In other words, like if the idea that we would add something to everything would mean that actually, well, it's we weren't considering that to begin with, within our everything. So
Yeah,
because
but
everything is
if something
everything.
just automatically adds to it, then that's just part of the universe at that time.
But
It's
that's what I'm
just
saying. The universe conceptually cannot include anything else. It includes everything. You can't add to everything conceptually.
if you add to it, then that would just be part of everything at that point.
It can't, logically, think about this in terms of logic. If I'm using the term everything to describe everything, then anything that you might posit we'd be adding to it would simply be a statement of ignorance, that we didn't really know that it was part of everything, because again, everything has to be everything. You can't logically add
I
to
I think
everything.
you're I think you might be confusing everything at one moment of time with everything at another moment of time. Uh, it could be the case that everything at one moment of time has isn't the same everything as everything in the next moment of time.
No, the universe. When I say is everything, I mean it both temporally and spatially. In other words, like everything, in every past moment in time, in every future moment in time, as well as everything in the linear directions of space. Everything has to mean everything, uh, logically. By definition, you can't add to everything.
So
Everything
I
already
think you're
includes
kind of
everything.
postulating what's called this is a time discussion that we might have to have another discussion on. But I think you're kind of talking about a block universe where everything, including the future and the past, all exist.
No, 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 absolutely not. I wouldn't say that. I don't hold that opinion. In other words, like the
Okay.
past. No, no.
Okay,
This
because if not, then you are saying everything at one moment of time rather than everything temporally. So
but
if you say everything temporally, then you mean that there's a block universe and the future already exists. So we can't have acausal events because we already know what exists in the future. We don't know, but we already something already exists in the future.
well, again, I don't believe in the block universe. I believe that that, like, in other words, like this last
Why
moment.
not? Why don't you believe in the block universe?
I don't see any evidence of it. In
Yeah,
other
I
words,
agree
the
with him
block
on that.
universe is saying that
Whoa,
everything is
whoa,
happening.
whoa, whoa. You talking about special relativity? That's how you get the block universe. You have to violate the relativity of simultaneity in
I
order to not get
disagree with
block.
that. I disagree that special relativity and the creates the block universe. I think that's Green's position, but I think he's mistaken on that.
Well, I want to
Totally
respond to
true.
what George was saying here, because I think I agree with what George is saying, because if the universe is everything, and then to suggest that you can add something else to everything, that something else would have had to already been part of everything, so it couldn't truly be added.
Why would it have to be part of it?
Because if it's everything, that means that includes wherever you pulled the stuff that you added from.
It's everything at one moment of time, and then the next thing is everything at the next moment of time, which could include an event that just popped into existence.
But so okay, so I'm this is a little confusing here. But to say that something was added, well, where was it added from?
It wasn't. It's acausal. If it was
Oh,
added from something, then it would be causal.
trick. Like when we're saying everything at one moment in the universe, that would mean everything. So then to posit that something was added in the second moment, or the subsequent moment, it's still being quote unquote added from the everything that existed in the
No,
previous
it doesn't
moment.
have to be added from the thing before because it's acausal. It just pops into existence.
Guys, for this, let's just take for an example, for us to prove that an acausal event that happened, that that something could pop in or out of existence, we would have to be able to measure the entirety of the universe, everything, all matter, all energy, and know that that volume, that amount we measured, was constant, or if it changed, because if it changed, then there would be a creation and destruction of matter, which would mean that that principle is gone, and which would imply that acausality might be happening.
Well, that wouldn't really be proof of a causal event. That because it could come from somewhere else or whatever.
But there is no somewhere else. We're talking about the whole universe, everything.
Okay. Okay. Yeah. If you're people don't use universe in that. I know that's it. All depends on how you define universe.
Yeah, maybe for our listeners, we just need to clarify that when George or I talk about the universe, we're talking about not the known universe. We're talking about the known and the unknown universe. Everything that exists, even if we don't know about it yet.
Right. Right. Because if you're talking about multiverse theory, then you have multiple universes and things like that. So
Right, and all those multiple universes are part of one big universe, reality, cosmos, whatever.
okay. So yeah, if we're able to determine everything that exists, obviously, and then the next moment everything exists plus one thing else, added, then obviously we've shown a causality. Yes, you're correct on
Exactly,
that.
that's what I was getting at.
So what's a block universe?
That's
Is it
it's a
anything to do
theory
with
of time.
Minecraft?
It's a theory of time basically that says that the past, the present, and the future all exist simultaneously. So there's no changing any of that because it already exists.
I don't get that because like it would seem like evidence argues
You just
completely against
destroyed
that.
David Joseph. He was like silent after. He's like, "Whoa."
Yeah, that just blew me away.
Yeah, that's and I don't buy into the block universe. A lot of people do. A lot of even physicists, they all a lot of people buy into block universe of time, but I don't think it's something that.
Guys, the way my brain works, when I hear block universe, I'm trying to picture all of reality and it's in the shape of a giant cube. Because to me, that's what a block is.
It doesn't have to look like a cube. It could look kind of like a cone where you have a big bang and it expands out over time. And that's just the direction of time. It's the direction of time goes in the direction of entropy. And that's just the whole existence of time all existing at once.
Yeah, if you could think of it this way, think of your length, width, and height, the three dimensions, and then you have time, which kind of extends. So you have your length, width, and height. Think of a block for length, width, and height, and then think of that extending through time. So that all exists for the block universe. You have the past where that block exists, and the future where that block exists.
Right. So basically, like let's take a rectangular video file where there's an image at each frame. Each frame is an image, which is like the state of the universe. And time goes forward or backward as if somebody could play forward or play backward, or skip to the frames of this universe, if the universe was a movie file or something.
Try to. I guess one way you could look at it is imagine as if every single moment of the universe was pressed onto a DVD. They all exist at the same time, but in different parts of the DVD you have different frames. So right at the beginning of the DVD, near the circle where you put it in, that's the first moment of the universe, and the last moment is towards the end, all the way at the perimeter of it. But they all exist ontologically, but they're all ordered from first, second to last in that way. But there is no objective now because every moment is now. It's just like there is no objective here on Earth. It's just like wherever you are at right now on Earth, that's what is here to you. Just like wherever you are in the black universe, that's what is now to you. But your now is not objectively true. Everything is now.
All right, but
But
Mike,
the
you're saying that's derived from relativity?
That is
special
the
relativity.
special and general. It comes from special relativity, but general relativity adds on to it. But that is the mainstream view in science.
Right, but wouldn't the problem, if it comes from relativity, be that relativity is a theory that explains basically objects relative to each other. In other words, like when basically it's a subjective quote unquote theory that, for example, like um, the the opposite of relativity would be, I would say, objectivity, in the sense that like let's say you have two, like the one person moving faster than the other, aging faster than the other, whatever. Um, that's kind of like the relative view. But then if we would consider it from the objective perspective rather than relative perspective, that there would be an objective reality.
There is no objective perspective. Every perspective is relative to the reference frame, and that is due to your position and your speed relative to other stuff.
Well, I mean, I can understand that in terms of observation, that we as subjective beings cannot perceive the objective because you'd have to be the objective to perceive that. But I'm not sure we could argue that the objective doesn't exist because it's
It
inaccessible to
doesn't.
us.
It doesn't say that the objective doesn't exist. It's like kind of looking at a car from different angles. You see it longer and I see it shorter because we're looking at it from different reference frames. But the car is objective. It exists. So in special relativity, things that happen are objective, but the order in which they happen is relative to your position and your speed relative to other things. It's
Right.
relative to your reference frame.
Exactly, Mike. So I agree with you completely. So you're saying like relatively, the ordering would be, up to our position, but objectively, even though we can't, access that knowledge, that ordering might be different than from our relative perspective.
Yeah, me and you could observe the same thing, and you might say A happens first and then B. I might say B happened first and then A because of the relativity of simultaneity.
Right, but then the C component would be that objectively, let's say maybe they happen both at the same time.
Well, you could never say that two events separated by distance happened at the exact same time. Objectively, you could only say that relative to a subjective reference frame.
Excellent. Okay.
Yeah. So if I'm passing you by, for example, going at a certain speed, you're technically passing me by at a certain speed. And for me, time's going slower for you and vice versa. So relative to me, that's at least that's what special relativity says, that for each person time is running differently.
Okay, guys, this may be a bit of an aside, but like here's the thing. The Big Bang is the accepted, theory of the universe. It's the standard theory, whatever. And basically it says that the universe, at the time point of the Big Bang was compressed to a singularity smaller than the size of an atom, So like, all right, that's our standard understanding. Then our next understanding is that it expanded. And yes, it didn't expand like an explosion. It expanded like a balloon, fine. It expanded, but so like it expanded to the present state of the quote unquote known universe now, right? We're not including everything. But here's what I don't get. So like the other part of our standard understanding is that like the universe cannot be said to have a center. Whereas to my mind, that singularity, that when the universe was smaller than an atom, that has to be the center. Because how would you explain, the expansion of coming out from something else?
I think you're baffling us, George.
Yeah, I'm lost, completely lost.
Are you saying, George, that because the universe can be traced back to a single point, and then if you go back to that point and play it forward, you see it expanding like a balloon, that there must be, or probably would be, a center of it somewhere?
That's exactly what I'm saying, Mike. Yes.
I don't think the word center is meaningful. I think that's the issue.
Why? But like, if we're saying, because like we're using geometry, we're using basic geometry to say the universe at
even in mathematics, the word center is a relative term. It really depends what kind of geometry you're doing. It's not
Whatever.
always
And it's not expanding evenly either. I mean, we use the kind of the balloon scenario to show like the expansion of the universe, but it's not really like that. It's not. I mean, you have some things that are moving slower. You have some things that are moving faster.
I get that, but if we posit, if we're starting from the premise that the universe was at a certain point in time, the Big Bang, smaller than the size of an atom, however it expanded, it has to expand outward from that infinite singularity size. How else can you explain the expansion? From where else can you explain it?
Right.
Well,
So
what would be the privilege of this center point, do you think? Do you think it would just be a point that has nothing special about it, or do you think that there's something special about it?
Well, I mean, in terms of special, the only speciality it would have is it's the origin. In other words, it's the Big Bang. It's the point from which the universe expanded.
oh, okay, but George, okay, so here's another issue we should talk about a little bit. This is an issue of human satisfaction. So some people, religious people, for example, they say, where did everything start? Where did things begin? And more scientific minded, perhaps secular people would say, okay, this is the origin of the known universe, of the way things are. But it's really about how content you are as a human being, because you keep saying the universe started with the Big Bang, which is true, but why are we not interested in the pre-universe?
No, and I am, because when I say that, I say the
Okay.
quote-unquote known universe. I agree
Okay,
completely.
so to me, the Big Bang isn't even.
So wait. Now we're
That's
saying universe as our universe. We're back to our universe now, right? Because we're switching back and forth between
yeah, we're
our
back to we're
universe
back
and the
to our
totality
universe.
of universes.
Yeah,
Right,
yeah, we're
Mitch
back
is
to
just
our
basically
universe.
saying, right,
No
there's
multiverse story right now.
that there's a universe outside of our observed universe.
I'm just saying before the Big Bang happened, there was something. There was a state that reality was in prior to the Big Bang. And
Right.
most people are content starting at the Big Bang. I'm saying, well, whether or not we can figure this out, there's still the other problem. What about
Yeah,
before the Big Bang? That's the
yeah,
Well,
but
real.
there's the
but
problem. The problem with that is that if the first moment of our universe is the Big Bang, and that is the first moment of all of time, then you can't ever say that there was a moment before that, because anything before that would be like having a DVD and rewinding it back to -5 seconds. There is no negative time on a DVD. There is the first moment of the DVD. That's where the movie begins, and you can't go back to negative time. There's literally nothing there. So there is no time before time.
Well,
and if we look at the balloon analogy, for example, imagine each galaxy is on the surface of that balloon. Okay, as it expands, each galaxy surrounds, and then it's not technically exact in that sense, but that's the analogy. Each galaxy is on that surface. The center, there's no center between like the inside of the balloon isn't the galaxy. It's what is expanding, the
Yeah.
roundness of it. Do you understand what I mean by that?
It would seem as if the
yeah,
center of the universe would be actually on the periphery of the universe, because that's what it expanded out, and the center universe would just be space. There wouldn't really be a center at all.
well, no, I mean, I can't understand that relative to our accepted understanding that at a certain, at the Big Bang point, the universe was compacted to a size smaller than an atom. Because that to me, like that has, you know, that has dimensions, that has length and width. That
But
it
again, this is an issue of human satisfaction. Look, so sometimes we're talking about philosophy, and other times we're sort of touching upon areas of scientific rigor. And whether or not it's not satisfactory, that doesn't mean it's not true. Right? We,
Right.
we use language to make it easier as beings that are not always concerned with logic and reason. Organisms that have emotions, that are under the influence of chemicals and things like that. So language is comforting. It helps us communicate. So we unfortunately, the fact is going to be sometimes there are going to be words like center and beginning and measure and time that we're not going to be satisfied with. And the only meaning they will have is within the context of a particular scientific discipline.
And
All right.
guys, I wanted to bring it back to, our original topic was about
Yeah,
causality, and it's sort of this universe of this podcast expanded into something entirely unknown to me,
But wait a minute. Actually, this relates because Mike, I want to address something you said relative to what Chandler just said about this causality causality thing. You're saying that time began with the Big Bang, which would imply that anything before the Big Bang wasn't caused. Because I think causality requires time, but I mean, is it more precise to say that our first knowledge of the existence of time is the Big Bang? Before the Big Bang, we just simply don't have the information by which to empirically conclude that there was time, or
Yeah,
there
Yeah,
was.
I'm saying that
well,
it's before the Big Bang is speculative right now. When I said what I said earlier was under the assumption that the Big Bang was the origin of all of time, but it may not be. There could be another universe that our universe popped out of, in which case our universe would have a cause and there would be a time before the Big Bang. But right
right.
now we just don't know. So what I've said before was just under the assumption, like given an absolute starting point of time, there cannot be a time before that. That is incoherent.
Right.
And therefore, there can't be a cause before it, because that would also be incoherent. So any
If there's a
origin
starting
moment
point.
of time, yeah, any absolute moment of time could not be caused by something external.
Right, and like, can we kind of like appreciate that question seems to transcend logic? I mean, because like logic is the foundation of our science, of our math, of our understanding. Yet we have the questions of infinity and temporalness, time, that both, and that's what the universe is. It's time and space. That the very essence of the universe transcends logic.
Well, why does it transcend logic? I don't understand.
Because like as Mike was suggesting, um, it's equally logical that the universe existed eternally
Right.
as to posit that that it had a beginning.
I
So,
disagree.
so you're saying basically we can't conclude such which option it is, whether it's infinite or there was a starting point logically, and that I would agree with. At least currently, we don't have that information.
Huh.
There are a couple of different cosmological models. Some of them which posit that there is a universe before ours, and from our perspective, time would look like it's going backwards. Imagine like two cones coming out from a point, and in that universe, time would appear from us to be going backwards. But if you were in that universe, time would be going regularly as normal. But the direction of time is in the direction of the second law of thermodynamics, is direction of entropy. But it's like two universes seemingly coming out from a single point of a low entropy state, and they're both in each direction infinite into the future for each of them during the direction of time. So that's one model, which is possible.
Well, Mike, let me ask you something. Is that model possible based on a mathematical equation or a mathematical calculus?
It's a mathematical model, yes.
All right, because the reason I say that is because, like, for example, in quantum mechanics, there are many equations that are time symmetric in that, like, they work equally well, time going forward in time and going backward in time. But
Hmm.
we know there's such thing as an arrow of time that, to the best of our knowledge, it only goes forward. And for example, like, to better explain this, like, math says that you can subtract 2 from 1 and get a -1, but we can't translate that mathematical understanding to mean that you can subtract 2 apples from 1 apple and get, as a physical entity, a negative apple.
I speaking of time and all this stuff, I just wanted to mention that we are just about to hit the 1 hour mark on our recording time, and so I think I really need to like wrap up this episode, but we should continue this in future episodes and stuff. Is it all right with everybody if I end this?
Sounds good.
Sounds good.
Okay, you've been listening to Free Will, Science, and Religion with a total of 6 co-hosts, it looks like. And it started out as a discussion about whether acausality was logically possible, but then it turned into relativity and confusion over different uses of the word universe. And so I think my co-hosts are going to have to continue this discussion after this recording ends quite a bit, and perhaps prepare for the next time that we cover it and make it more clear, because this is confusing and it's confusing me, and so I'm sure it's confusing our listeners. But if you enjoyed this, then great, and thank you for listening, and goodbye.